Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started on this video, I'd like to ask you to please give this video a thumbs up, hit the subscribe button, and engage with a comment below. In this video, we're looking at Unit 1, Constructions and Rigid Transformations, Lesson 11, Defining Reflections. The learning goal in this lesson is to reflect some figures, meaning we want to flip them over across an axis that we create. So maybe think about flipping something from being up to flipping it upside down, or something that's on the left side being flipped over to be on the right side. But that's what we're going to talk about when we say reflecting some figures. We have 2 learning targets in this lesson. Once we get done with the practice problems, we will come back and review these to ensure you learn everything you need to in this lesson before you move on to the next one. So learning target number 1 says that I can describe a reflection by specifying the line of reflection. So in order for us to say that something has been reflected or to describe how it was reflected, we need to be able to specify the line of reflection. Did it reflect from the left side of the y-axis to the right side? Did it reflect from the top side of the x-axis to the bottom side? Did we create a random line and then reflect the shape over that line? The first thing we've got to do is specify that line that we're going to reflect it over. And then learning target number 2 is simply I can draw reflections. So your first step is going to be deciding where is that line that you're going to reflect over, and then part 2 will actually be doing that reflection and being able to draw that reflection. For glossary terms, we're going to start with assertion. This is a statement that you think is true, but you have not yet proved. So we can make a statement, but until we go through the process of proving that statement is simply an assertion. Next, we have congruent. One figure is called congruent to another figure if there is a sequence of translations, rotations, and reflections that take the first figure onto the second. So we can take the first shape, and if you notice here on the right, to go from A to B, we translated it down and to the right. To go from B to C, we then rotated it clockwise. And then to go from C to D, we reflected it across that center line between the two. What we didn't do was change the size of anything. The side lengths are all still the same. The angles are all still the same. Therefore, it is congruent because all we did was move it. We did not change the size of it at all. Next, we have image. If a transformation takes A to A prime, then A is the original and A prime is the image. So if you notice on the right side of the screen, we have an example here. The bottom left triangle would be considered the original triangle with points A, B, and C. And then it is simply translated up and to the right. And now point A becomes point A prime. Point B becomes point B prime. point C becomes point C prime, and now this new triangle that we have created is considered the image triangle of the original one that was down in the bottom left. Next one is reflection. A reflection is defined using a line. It takes a point to another point that is the same distance from the given line, is on the other side of the given line, and so that the segment from the original point to the image is perpendicular to the given line. So looking at the image on the right in the figure, A is the image of A under the reflection across the line M. So M would be considered its perpendicular bisector. So we can simply take A and reflect it across M to create A prime. It's the same distance away, so we would consider A as the original and A prime as the image. Next, we have rigid transformation. A rigid transformation is a translation, rotation, or reflection. We sometimes also use the term to refer to a sequence of these. So here's that example we looked at earlier. To go from A to B, we translated it down and to the right. To go from B to C, we rotated it clockwise. And to go from C to D, we reflected it across that middle line that they share. Our last glossary term is theorem. This is a statement that has been proved mathematically. So our first glossary term was assertion. That's when you make a statement and it may be true, but you haven't proven it yet. A theorem is that statement once you have proven it mathematically. So if you do have any questions about this introduction, go ahead and leave a comment below. If not, let's go ahead and move on to the practice problems. Now we can start on the practice problems for lesson 11. Which of these constructions would construct a line of reflection that takes the point A to point B? So remember, a line of reflection is the line you reflect across to create the reflection. So let's take each one and see if it does that. Option A, construct the perpendicular bisector of segment AB. So we're just going to take point A, point B, we're going to draw a line connecting them. Now, if I do the perpendicular bisector, that means I draw a line exactly halfway between them, and it needs to be at a 90-degree angle. So now, if I reflect across that line, I do in fact take point A, reflect it across that perpendicular bisector, and create point B. So that is exactly what we were looking for. Let's try the others just to be sure, though. On B, they want us to construct a line through B perpendicular to the segment AB. Well, same thing. I'm going to draw point A. I'm going to draw point B. And I'm going to draw the segment that connects them. But this time, I'm going to make this line perpendicular through point B. Well, now, if I were to reflect point A across this dashed line that I just drew, it's actually going to be somewhere out here. That is not point B. So that is not what we were hoping to do. So B would be wrong. Option C, construct the line passing through A and B. So I make my point A. I make my point B. And I have my segment connecting them. Or this one doesn't state segment, so let's not have that. But we want the line going through them. Well, the line would go on infinitely in both directions. If this is the line I'm going to reflect across, then A just also becomes A prime. It stays in the same exact place. So that did not take A and make it B. So C would not be correct. And then option D, construct a line parallel to line AB. So we're going to put point A. We're going to put point B. We're going to draw a line going through them. And now we want to construct a line that is parallel to this. Well, parallel means they never intersect. They run side by side. And now that I've created that line, if that is my line of reflection, then when I reflect A across that line of reflection, it's going to put A prime right about here. That does not take A to B. So D does not work either. I hope the explanations and the diagrams help this make sense to you. But if you do still have any questions, please feel free to leave a comment below. Practice problem number 2. A point P stays in the same location when it is reflected over line L. What can you conclude about P? So we need to understand that when we say it is reflected over line L, we're saying it's reflected across line L. Now, you can think of this line as a rod or a straw. And think about rotating this straw 180 degrees. So if I had a point A right here, then when I rotate this 180 degrees, this point is going to come straight across and be here on the other side. But they're asking us, where could we put this point P that it would stay in the exact same spot when we reflected across? So go back and think about if you took this line in your fingers as a rod or as a straw, and you rotated that 180 degrees in your fingers. If you had a point sticking out from the straw, then that point would move. It would move 180 degrees to that same distance on the other side. The only points that are not going to move are going to be the points that make up the line itself. If I held a small rod in my hand and I twisted it in my fingertips 180 degrees, the rod is still in the same place. So that's what we're going to say here. The point P would need to be somewhere on this line. Anywhere I put a point on this line, then it is going to stay in the exact same place if we reflect across the line. So we can say point P must be a point on line L itself. It must be one of the points that is making up that line. Otherwise, it would change sides. So I hope this explanation and the diagram makes sense to you. But if you still have any questions, please feel free to leave a comment below. Practice problem number 3 is the last practice problem in lesson 11. Lines L and M are perpendicular with point of intersection P. Noah says that a 180-degree rotation with center P has the same effect on points in the plane as reflecting over line M. Do you agree with Noah? Explain your reasoning. So let's go ahead and try the 180-degree rotation first. And I'm going to do this with 3 different types of points. Point A, I'm going to put on line M. If I do a 180-degree rotation, it's going to come around, and now A prime is going to be down here at the bottom. The second point that I'm going to use is going to be point B that is not on line M or line L. If we rotate around clockwise 180 degrees, then point B prime is going to be down here in the bottom left. And the third point that I'm going to use is point C on line L. If we rotate clockwise 180 degrees, then point C prime is over here. Now let's see if Noah is correct. If I take point A and I reflect over line M, then because we would be going from left to right or right to left, a point on line M is going to stay in the exact same spot. So this I'll call A double prime. Notice it is not in the same spot as A prime. This means Noah is wrong. If we look at point B, reflecting over line M will take it from the top right over line M and put it in the top left. We'll call that B double prime. Notice it is not in the same spot as point B prime. And the last one is C. If we reflect point C over line M, it ends up where C prime is. So the only time Noah was correct is with points that are on line L. So Noah is only correct when points are on line L. He is incorrect for all other points on the plane. If Noah had been correct, then A prime would have been in the same spot as A double prime, and B prime would have been in the same spot as B double prime. But because we resulted in different points for these two examples, that means any point on line M is not going to be the same, and any point off of lines M or L will also not be the same. I hope this helped you out. I hope this makes sense. If not, please feel free to leave a comment below. Now let's go and review the learning targets for this lesson and wrap this video up. Looking back on the learning targets for lesson 11, number 1 says that you can describe a reflection by specifying the line of reflection. Remember, if you are doing a reflection, then there must be some line that you are reflecting across. So you need to be able to identify that line when you are describing it to someone. It may be an axis. Maybe you're reflecting across the y-axis, or you're reflecting across the x-axis. Maybe it is a random line or line segment that is drawn in open space. But you have to be able to specify which line it is that you are reflecting across. And then learning target number 2 says that you can draw reflections. That simply means you understand that once you know where your line of reflection is, and you know which point you're reflecting across that line of reflection, then you understand how to move that line straight across the line of reflection in a perpendicular motion so that it ends up in the same spot on the other side. It's the same distance away from that line of reflection, and it is drawn in a way that would be perpendicular to where the original one was. So try some of these, keep practicing them. I hope everything in this lesson has made sense to you. If not, as always, feel free to leave a comment below. But if you did find this helpful, then please give the video a thumbs up. In the bottom left of the screen, you should see a video that YouTube is recommending. In the bottom right of the screen, you should see the subscription button for this channel. Please help support the channel. And I look forward to seeing you in the next lesson.